So welcome students. So in this question, given that you have an ellipse with length of major axis 10 and the length of minor axis 8 units, and a circle is drawn with one of the foci of the ellipse as center, such that the circle just touches the ellipse and the circle completely lies inside the ellipse. So in that case, what is the radius of this? What is the radius of this circle? That's the question. So now my center is focus, and as you increase the size of the circle, there will be at one stage where the circle will be tangential to this ellipse. So in that case, these two, the circle and this ellipse, will have a common tangent because they are touching each other. That means at the point of contact they have a common tangent and also a common normal, So let us say that this normal equation, let us try to find the common normal. So where is the point at which the normal passes through the center of the circle? Because we know that in a circle the normal always passes through the center. So we have to find the point where you can draw a normal such that it goes through the focus. That will be the point of touching. So you can have different forms. These are the different forms of normals to the ellipse x square by a square. So a is equal to 5 and b is equal to 4. So x square by 25 plus y square by 16 is equal to 1. This will be the equation of the ellipse. Now let us, the more convenient form is, let us take the parametric form of the, so let us say that this point has a eccentric angle theta. So what is the normal at this point? The normal is ax, a is 5, a is equal to 5 and b is equal to 4. So now let us take the equation of normal. Let us take any one of these equations. So let us take the slope form. So the equation of normal is y is equal to mx plus or minus m times a square minus b square. 25 minus 16 is 9 by root of a square 25 plus b square is 16 m square. So now for this normal to be a common normal to both the circle as well as the ellipse, if this has to be a common normal to ellipse as well as the circle, this is always a normal to the ellipse for whatever value of m. This also has to be normal of the circle. This has to pass through the center. So center is the focus. So how do you find the focus? So focus coordinates are a, 0, where e is equal to root of 1 minus b square by a square, that is equal to root of 1 minus 16 by 25. So 25 minus 16, 9 by 25 square root is 3 by 5. So e is 3 by 5, a is 5. So a, 0 is 3, 0. So the focus is 3, 0. So now this has to pass through 3, 0. So let us see what the value of m is, so that this line passes through 3, 0. This implies 0 is equal to mx plus or minus 9m by root of 25 plus 16m square. So one of the answer is m is equal to 0. If I take m as common, so m is equal to 0, or x is equal to plus or minus m is equal to 0, or so this has to pass the 3, so 3. So 3 is equal to plus or minus 9 by root of 25 plus 16m square. So 25 plus 16m square is equal to, so 3 by 9 is 3, square is 9. So this implies 16m square is equal to minus 16, which is not possible because m square is always positive. So there is only one option where m is equal to 0. That means the slope has to be 0. That means the common normal has to have a slope 0. That is, the common normal is, so if you put m is equal to 0, so you get y is equal to 0. That means x-axis. So x-axis should be the common normal. What is the meaning of this? That means these two curves are intersecting on x-axis. That is, this point is 5, 0. So this circle and this curve actually intersect on the x-axis. So this point is 3, 0 and this curve they touch this ellipse. The circle touches this ellipse at 5, 0, hence the radius is equal to, the radius of the circle is equal to 2 units. So, that is the answer to this question. Thank you.